Okay, so we left off talking about multivalent and what a multivalent metal is. In the transition metals, you have, if we go back to our periodic table, you have some of these transition metals like iron or tin or lead or gold. They all have, or where else? Copper. Okay, they all have different charges, and multivalent metals. Um, are similar to monovalent, but multivalent just have two potential ionic charges that they have there, and we have to be able to distinguish them when writing chemical formulas. Okay, and there are two ways in which we do this. The first way is the stock system, and this is a use of Roman numerals, and I'll accept either one unless on a quiz or something I specify use Roman numerals or use the Latin way. So the first way is the Roman numeral way. Okay, and this uses Roman numerals in the name to only to indicate the charge on the metal ion. For example, we have Sn, which is tin. Okay, so tin chloride, and we know that there's two chlorides. We know that we do a reverse. If we do a reverse crossover method, the two comes up here, and we have tin chloride. Okay, so tin 2 chloride. Okay, and if we go to our periodic table, we look for tin, tin right here. Okay, we see that tin does in fact have a ionic charge of +2, so it would be a tin 2 chloride. Okay, so for each of these, I want you to take well, I'll walk through them with you, and then I'll give you a couple examples for you to do by yourself. So name each of the following using the stock system. So this is the Roman numeral system, the stock system. Okay, iron, so Fe is iron, chloride. Okay, if we do reverse crossover, my 3 comes up to my iron, and my 1 comes up to my chloride, and I'm left with iron 3 chloride. Now let's go to iron and see if iron does in fact have a +3, and yes, it does. So iron 3 chloride, it takes 3 chloride to take on the 3 electrons that were here on the iron molecule, right? So we know that iron, because it's iron 3 chloride, it has 3 valence electrons. Therefore, one chloride will take one, the other chloride will take the other, and another chloride, so 3 chloride to take on the 3 electrons. Okay, next one we have uh, copper oxide. Okay, but we don't know what the actual charge on copper is. So if we bring this charge up here, okay, we do a reverse crossover, so the 2 comes up to here, the 1 comes up to here, and then I'm left with copper 1 oxide. Okay, remember IDE for the non-metal. Now let's go to our periodic table to see if copper does have a +1 charge. And yes, copper does have a +1 charge. Okay, therefore, oxygen, we know that oxygen has a -2 charge, right? So we see that oxygen here has a -2 charge, right? Because it's in group 16. So group 16 has a -2 charge, oxygen has a -2 charge. Um, Therefore, it takes 2 copper ions, okay, positive ions, takes 2 copper 1 ions to fill the valence shell of oxygen. Okay, just like the one before with iron, okay, it takes 2. So 1 copper 1 ion goes to oxygen, another copper ion goes to oxygen to provide it with the appropriate amount of electrons to look like that noble gas that we were talking about earlier on in the lessons. Okay, and then we have lead oxide. Well, this one doesn't have any subscript, so we can assume that this is 1 to 1. Okay, it says a 1 to 1 ratio, but we know that oxygen for sure has a valence has a 6 valence electron, so therefore it has a charge of -2. We know that 100%. Why? Because oxygen is a non-metal and oxygen is located in group 16, right? So if we go to our periodic table, okay, we know that that oxygen is monovalent, like it only has one charge it could possibly be, and it's -2. So because it's a 1 to 1 ratio, we can simply assume that lead will have a +2 charge because again 1 to 1 ratio. So if we go back here, in fact it does. So the crossover is lead 2 oxide, and I simply just use the Roman numerals in order to determine that. Okay. So provide the formula for each of the following. Gold 3 oxide. Okay, so this gold we know has a charge of um, 3. Okay, and we know that oxygen has a charge of 2. So if I do the crossover method, let's go to the Jamboard here. Okay, if I do the crossover method, Au3 and then oxide 2. Okay. Oh, sorry, not down there, up here. 2, I'm going to do crossover method, and I'm left with Au2O3. Okay, so that would be that one. Tin 4 oxide. Okay, so tin 4 oxide, let's go back over here. Actually, you know what? I kind of did it here for you. So tin 4, we know that there would be a 4 up here. Let's go here. So tin 4, tin has a charge of positive 4. Okay, and oxide has a charge of negative 2. We're going to cross over, and we're left with tin 2O4. Okay, but again, lowest, this is not the appropriate ratio, so we can cancel these out, and we take out a 2, right? And we divide both by 2, and we're left with tin O2. That's not a Z, this is a 2. Okay. Again, right here, same thing right here, okay? So that's one way that we do it, using Roman numerals. And that's a pretty easy way to do it. Roman numerals, you just need to know your Roman numerals. V is 5, so 1 minus V is 5. If the 1 was on this side of the 5, it'd be a 6. But you should know your own Roman numerals. If not, there's a beautiful thing called Google, and it'll help you out as well. Okay, there's 1, 2, 3 sticks there, so that's 3. Anyways, let's move on to the classical Latin system. Okay, so the classical Latin system uses the ending OUS and IC, so us or ic. So us is ending given to the metal with the lower of the two charges. OUS is given to the metal with the lower of the two charges. Ic is given to the metal with the higher of the two charges. Okay, this right here, okay, this right here would have a charge of 2. This iron here has a charge of 2. This iron here has a charge of 3. So it would be ferrous. This one you would use the OUS right here. Don't worry about ferrous right now. This one you'd use OUS, and this one you would use ic. Okay, but how do we know what the actual names are of these things? The Latin names. Remember how I said that a lot of these chemicals or atoms come from, or elements come from Latin names. So iron we know is an Fe, well, because iron ferrum. So Fe for iron, ferrum. Okay, and that's why it has the chemical symbol of, or the elemental symbol of Fe. But anyways, iron, okay, ferrum, and then if we have ion with the lower charge, it'd be ferrous. Ion with the higher charge would be ferric. Lead, plumbum, I don't know, plumbum. uh, that's a silly name, isn't it? Uh, plus, still makes me laugh. I'm pretty. That's pretty funny. Plumbus would be the lower charge. Plumbic would be the higher charge. Cuprum, cupris, cupric. Gold, arum, eris, eric, and then tin, stannum. That's what tin is. Stannis and stannic. Okay. Ulrich, I guess, not Eric. Ulrich would be gold. Okay, so we're going to name each of the following compounds using the classical system. This is the Latin system. Okay, so iron chloride. So we use the crossover method. We bring up the 3 here. So we bring up the 3 here. We bring up the 1 there. We know that iron is a positive 3. Therefore, it's iron 3 chloride. Okay, and if we go back to the periodic table, we see that the higher of the two charges for iron is 3. Okay, and because the higher of the two charges is 3, we can use the ic. What's it called? The ic ending suffix. Okay, so it would be ferric chloride. Then we have copper 2 oxide. Well, we're going to do the reverse, reverse crossover. So my 2 is going to go up to my O, my 1 is going to go up to my copper, so it's going to look like this. Copper oxide, and I know that that's copper 1, so it'd be copper 1. Sorry, it'd be copper 1 is the lower of the two charges, so the suffix is OUS. This is copperous oxide. And if we go to our periodic table, where's copper? Copper right here. Okay, copper 1 is the charge, therefore copper 1 would be the appropriate one. If it was copper 2, let's go back here. So if this was copper 2, it would be just CuO. There would be no subscripts here, right? If it was copper 2, if we use copper 2 in this situation, it'd be Cu, no subscript, O. The reason for that would be because copper has then a positive charge of 2, and then oxygen there has a negative charge of 2, meaning that they would cancel each other out, and there would be 0 subscripts, and it would be CuO, okay? If it had, if we use copper 2. If we use copper 2, it would look like this. Copper, right? So just so you're aware that that's why, you know, we know that that's copper 1 and not copper 2, because copper 1, you would need 2 copper ions to fill the valence shell of 1 oxygen ion. Okay, so I want you to try this one by yourself. So pause the video right now, try to do this one by yourself. Let me know what you think. Let's go back up here to see what PB is. PB is lead, plumbum. So you got either plumbic or plumbis. So right here, pause the video. PbO2, which one are you going to use? After you've paused the video, the answer is right here. It'd be plumbic oxide. It'd be the higher of the two. And if we go to our periodic table, Pb has positive as a 4. We know that oxygen has a charge of -2. So if we go to here, we have PbO2, or sorry, subscript of 2. Okay, PbO2, we do reverse crossover. We're left with Pb positive 2 charge, and then oxygen has -1. Okay, we know that oxygen does not have a -1. Okay, we know that oxygen has a positive 2, but because there's 2 oxygens to fill the it needs 2 oxygens to fill the valence shell of both oxygens. You would actually have to do Pb positive 4, O -2. Okay, and then if we do that crossover, it'd be Pb2, oxygen 4, but these would have to divide by 2 to leave us with Pb oxygen 2. Okay, this is not an ion, right? We know that this is not an ion. Oxygen does not have a, what's it called? Have a charge -1. We know that it has a charge of -2, so really what you have to do is multiply both by 2. Okay, and that would give you the appropriate answer. Okay, and oh, let's keep going here. Sorry. So if we look at provide the formula for each of the following. So Aris sulfide OUS is the lower of the two charges, so therefore it has a +1 charge. So let's go to our periodic table. Au, gold, we have a +1 and +3. We know that OUS is the lower of the two, so OUS will be of the +1 charge. So this one will be Au2 sulfide. And then stannic IC is the higher of the two. Therefore, you would have to look for the, you look for the one with the highest charge, and that's a +4. Okay, so therefore you go SnO2 with the reverse crossover method. Okay, guys, I hope that makes sense. If you have any questions, just let me know. Send me an email. We're going to also have, I guess, office hours later on. Sorry, I just spelled this wrong. I just want to change it. So hopefully we can get any questions questions answered and use the office hours again to your advantage. All right, guys, take care, and we'll see you later. Bye.